Hello back, welcome back another episode. Today's episode we are going to talk about sets. So today's episode is really important. So this is the part 2 of Python set methods. Today's video I'm gonna give you, or I'm gonna a quick reminder about sets, and we're gonna see some set methods that you really need to know about sets. So the first thing, Python set methods. Sets are unordered, and we saw that in the previous video. Set elements are unique. Duplicate elements are not allowed. A set itself may be modified, but the elements contained in the set must be an immutable type. So this is the first thing. Today's episode we have our first method is union. What is a union? Union, it's like we join two things together. So we have first set and the second set. So we're gonna join them together. So let's see how it works. I'm gonna set we have this sets, and I'm gonna set print x1 dot union x2, and what I'm gonna get is one set. It's onion this and the second one. So this is the first thing. This is the method. You can use operator. So operator, it's the same job. There's no difference. There's a little difference. But we don't want to talk about this in this episode. So what I'm gonna say, x1 and this operator and x2. I'm gonna get the same results. Yes. Let's jump to the third function, which is the first thing. There's note that the element pass, which appears in both x1 and x1, appears only once in the union set, never contain duplicate values. So here we have pass, and here we have pass. We can't get duplicate values in this situation. So in this situation we have just one pass. So this is a quick note. The first thing, or the second one, is set intersection. x1 dot intersection and x1 return the set of all of elements common to both x1 and x2. So what I'm gonna set, I'm gonna set like this. Intersection So intersection is method that we use to get to get value that's common between both x1 and x2. So in this situation we have pass because we have pass here, and in the second one we have pass here. So this is the first thing. You can do operator. In this situation I think I don't have this this thing on my yes. So let's jump to the next one, which is different. You can use this thing. Return the set of elements that are in x1 but not in x2. Again, return the set of all elements that are in x1 but not in x2. What does that mean? Here, let's say we have foo and far and bus. So let's say if we have here do difference. or you can use this. Here we have foo x1. It will give you return the set of all elements in x1 but not in x2. So foo not in x2, and far not in x2. You know. So let's say another one, for example, h. So what we get is, because h not in, you can use the same. So we have 2 and x1, and let's say you can use box here but not in another one. The second one is set symmetric different. Return the set of all elements in x1 or x2 but not both. What does that mean? It's a long episode, but not it's okay. So sorry, just so in this situation I'm gonna do symmetric difference. Return the set of all elements in either x1 or x2. So print x1 so here we have symmetric difference. Symmetric difference return the set of all elements in x1 or x2 but not both. Here box is in x1 x2 but not in x1, not both. Foo in x1 but not in x2. Buzz not h not in x2. So this is what actually sorry, I was with my brother, anyway. Yes. Yes, so this is episode. It was very, very important episode. Thank you, a big thank you for your support. And so in another episode we will talk about another set methods. This episode is really, really important. Thank you for watching this episode. See you another episode.